Hey guys, this is Mr. Sal. We're going to look at proportional triangles and slope. All this is going to do for us by making the triangles is to show specifically what the rise and run is. So number one, on the line to the right, choose any 2 points that lie on the line and make sure they're the coordinates that we can find. It should just be whole values for the coordinates or integer values. And then the second part of that, from the 2 points create a right triangle. The line itself will be the hypotenuse and the legs will extend from the 2 points and meet at a right angle. All right, take a minute and do those two with your neighbor. All right, I'm going to go ahead and choose a couple points on this thing. I'm going to choose this point right here. These are different colors. And this point is at 5, 6. And then the other one, I will choose this one at -2, -8. Now again, you may have chosen 2 other points than these, but these 2 work. And then I'm going to make a right triangle out of this, just extending the legs from the 2 points. So compare the points that you chose and your triangle with someone in the class and discuss these 4 questions. Did you both choose the same points? How are your triangles the same? How are they different? And what relationship exists between the triangles? 1 minute for these. Should have 1 sentence for those last 3 as well. All right. Now let's say that you chose 2 other points. Maybe it was, for example, like this one here and this one. And you just had a different triangle, which is okay. All right. I'm going to put these 2 on here just so we can compare these. So if we chose the same points, that's fine. If not, that's okay too. But how are the triangles the same? I mean, they're both right triangles. And they're both drawn from the same line, that blue line right there. How are they different? One's bigger than the other. In fact, we could say that one is a dilation of the other. So that gives us the relationship that exists between the triangles. For example, if we were to compare the rise and run on these, the red one has a rise going up, starting from here. Now, a lot of people have been confused on the counting process on this. So we always start at the point on the line. That's not 1, that's 0. Then I would go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one goes up 14, which as a rise would be positive 14. Well, then we need the run, starting from right here, and we're going to the right. So starting here, that's 0, 1, 2, 3, 4, 5, 6, 7. We went to the right 7. The right is in the positive direction, so that's a positive 7. If we were to simplify this, we would get 2. The green one, this one is still going to go up, but it's going to be less starting here. That's 0, 1, 2, 3, 4. So the rise and run for this one, the rise is 4. And then it's going to go to the right, 1, 2. Which is in the positive direction. So 4 divided by 2 is also 2, which means that the sides are proportional with each other, and that again is because one of these is a dilation of the other. Therefore, we would expect these to have proportional values, which should simplify to the same value of 2, which is what we have right there. So, given any 2 triangles with hypotenuse on the given line and legs horizontal and vertical, so this is kind of what it's talking about. If we had a line like this one, if we were to take a leg here that's horizontal and one that's vertical like this, then there's a dilation that takes one on the other. In particular, the lengths of corresponding sides are all multiplied by a factor of the dilation. So in other words, if I were to make a different triangle like this one, it just means that the big one is a dilation of the small one, or the small one is a dilation of the big one, and it wouldn't matter. In particular, the lengths of corresponding sides are all multiplied by the factor of the dilation, and so the ratio of the length of the vertical leg to the horizontal leg is the same for both triangles, which is what we just found. It doesn't matter which triangle we use, the ratio is the same for all of them because a dilation gives us proportional values. So the graphs given below have several different triangles formed from 2 points that lie on the line. These triangles are dilations of one another, and their corresponding parts are proportional. Answer the questions below about these lines to observe what this tells us about the slope. In each graph below, how many right triangles do you see? Also, trace each triangle you see with a different color, which we will do. And for each triangle, write a ratio comparing the lengths of its legs, or height over base, and simplify the ratio height over base. We're not going to use height over base though. We're going to be referring to it as rise over run because that is the slope. So here's our first one. Just looking at this, how many triangles do you guys see? There are four triangles on this one, okay? So we want four ratios on this one. That's all right, we'll give you some time to look. Take a minute with your neighbor and figure out all four of the ratios. All right, whether you start with, whichever triangle you start with doesn't really matter. I'm going to start with the big one though. So I'm going to trace it. Again, we're really focusing on rise and run, which will tell us the slope of this diagonal line right here. So on this one, I can see, for me, the rise and run. The rise on this one is going to go up, but how far up is it going to go? Starting here, because that's where the two lines meet. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this one goes up 13, which means the rise is positive 13. And then it's going to go to the right. Again, we're starting right there, which is the run. Yeah. So the run will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's to the right 13, which is in the positive direction. And 13 over 13 is 1. So that's our big triangle. Next one, we're going to look at this one right here. So this one starts by going up, starting from this line right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got up 10, and then we'll go to the right. Again, we're starting at this point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to the right 10 is also positive 10, and 10 over 10 is 1. Next up, we'll do this triangle right here, which is going up and to the right. And how far up does it go? Again, we're starting at the intersection of those two. Up, 1, 2, 3, 4, 5, 6, 7. So that's an up 7. And then the run, starting here, 1, 2, 3, 4, 5, 6, 7. So that's to the right 7, and 7 divided by 7 is also 1. Finally, we have that tiny triangle, which was up 1, and then to the right 1. It has a rise of up 1, and then to the right 1, which also gives us 1. Now again, just like we've been discussing, this is what we would expect, all these 1 values here on the right, because each of these is a dilation of one another. It'd be like taking that little 1 and then clicking on it on a computer and then dragging it over, which would give us this bigger triangle, or moving it over here to the purple one or the red one. Or you could say you move it down. It wouldn't matter either way. But the ratios are all the same, and that's what we would expect. Here's number 4. 4 triangles on this one. Find the ratio of rise over run. So 3 triangles on this one. And again, we'll start with the biggest one, which for me goes up and then to the right. So how far up does it go? We're starting with that intersection right there. It goes up 1, 2, 3, 4, 5. So that's a rise of up 5. So positive 5 there. And then to the right, which makes the run positive, starting from this line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the right 15 and 5 over 15 would give us a ratio of 1 over 3 as a fraction right there. Next up, the next triangle there. Again, this is showing up by how much? 1, 2, 3, 4. Now this one, we can do this a little differently. We see that the rise is up 4. But the run is just 3 less than that 15, because we're just going to take off those 3 right there. So 3 less than 15 would be to the right 12 on that one. Now this just saves us some time in terms of counting. The good news is that it still simplifies to 1/3. The green one, which will be this one right here, this one goes up 3. Yep. And then this one again is 3 less than the previous one, so that would be to the right 9. So as rise and run, the rise was up 3, and then to the right 9, which again simplifies to 1/3. And then this final triangle right here, this one goes up 2, and then to the right on this one, this one's not too bad, so you could count it starting here, 1, 2, 3, 4, 5, 6. So up 2 to the right 6 gives us another ratio of 1/3. Number 5, again we're finding these ratios, rise over run. This one has 4 triangles. There's one line on the x-axis right there that's thick. So find the ratios for all 4 of these. Same idea here. We got 4 triangles. Let's start with this one, which again goes up and then to the right. And this one starting at -6, we're going to do this one a little bit different. It goes all the way up to 6, which means that it has to go up 12. Now if you counted, you should get the same thing. But right there I have a rise of up 12. And then starting here at 1, it's going to go to 7 to the right, which means it has to go to the right 6. So I have 12 over 6, which would simplify to 2. The next triangle would be this one right here in purple. So this one again is going to go up and to the right. And again we're starting here at -6, going up to 4, which means it's going to go up 10. So a rise is up 10, positive 10. And then to the right from 1 to 6, that is to the right 5. So 10 over 5 again is 2. The next one, this one is kind of hidden there on the x-axis, but it will still go up from 6 to 0, -6 to 0, that would be up 6. So a rise of 6. And then going to the right from 1 to 4, you could count that 1, 2, 3. And 6 over 3 is 2. Last one, the smaller one. This one goes up from -6, 1, 2, 3, 4. So it's going to go up 4, and then to the right 2. And 4 over 2 is 2. Number 6 also. On this one, we're going to say I would say there's 5 triangles. Some people would say there's 7 though. But we're going to focus on 5 for this one. Alright, let's start with the big one again. This one is going to go up 7 to the right 7, which gives us a rise of 7 and a run of 7, which is a ratio of 1. The next one, it wouldn't matter which one you chose, but this one right here, looks like it goes up 5, and then to the right 5, which is again a ratio of 1. Next up, we'll look at this one right here, which is up 4, and then to the right 4, which also is a ratio of 1. And the next one here, this one is up 3, and then to the right 3, which again, a ratio of 1. And the last one we see would be this one right here, which is up 2, and then to the right 2, which also is a ratio of 1. Alright, then 7 and 8, we'll consider those 4 that we just did. So the ratios, rise to run, always simplify to the same fraction, even quadrants with negative ordered pairs. Why or why not? And number 8, how does the rise over run ratio describe the steepness of the line? Take 1 minute and answer both of these with full sentences. Talk about it with your neighbor. Alright, on 7, there's a couple answers we should get on this one. But the answer is yes, just the explanations may be different. So for us, we're saying that each of the triangles are dilations of one another, which makes the side lengths proportional. Or you could say something to the effect of, since it's a straight line, it has a constant rate of change, which means it's a constant ratio. and that is why they all simplify to the same thing. So either one of those explanations would work. On number 8, how does the rise over run ratio describe the steepness of the line? The higher the value, the steeper the line. So if we look back at the problems we just did, if the ratio is higher, like I think we did one that was 2, then it has a steeper line than one that has a ratio of 1, or even like 1/2 on that, okay? So the higher, and we know that in comparison, if the rise is bigger than the run, we get a bigger or steeper slope. If the run is bigger than the rise, then we get a less steep slope. Number 9, this one has 3 triangles, so find the ratios for the 3 triangles. This one goes to the right. How far? 4 and 8, 12. So it goes to the right 12. So the 12 is positive, and this would simplify to -3/4 on that. So yeah, since this one, I'm starting from this point here, I'm going down, which would make that 9 a negative in terms of rise. Because the downward direction for up and down, that would be a negative direction. Going up is the positive direction. Now you could have said, well, you went to the left 12 and then up 9. It just changes where that negative is in the fraction. But overall, its overall value is negative either way. Which we've looked at before, right? The rise and run have opposite signs, so we know that the slope should be negative on that. Alright then, let's look at the other triangles. So I got this one, still going down. And then to the right again. This one looks like it goes down 6. And then to the right, 8. So down 6, that's a -6. And then to the right 8, that's a +8. Which again would simplify to -3/4. We'll do the next one different, but we'll show it's going to be the same no matter what. Again, I'll say on this one that I'll go left and up. So in this case, we'll say that it goes left. 1, 2, 3, 4. Now that's the run, which is -4. And then we'll go up. So left 4, and this goes up 1, 2, 3. So we went left 4 and then up 3. Again, it still has the same value as the -3/4. It's just, again, changed where that negative is. On this one, if you did go down 3 and then to the right 4, you'd still get the -3/4. Again, it's just changed where that negative is. So they'll have the same value on this. All right, take 1 minute and do number 10. There's 3 triangles on this one. All right, here we go on this one. So, again, I'll draw the 2 triangles, or 3 of them. So this one goes up 2 and 7, that's 9. So this one's going to go up 9, so that's +9. And then to the right, 8 and 4 is 12. So that's a +12, so this one is a +3/4. The next one, this one is going to go up 6. And then it looks like it goes to the right 8, which again simplifies to 3/4. And then this last one in green right there, that's going up 3. And then to the right 4, which still is 3/4. So we're going to compare 9 and 10. Number 9, this one had a slope of -3/4. And the one on number 10 had a slope of +3/4. We'll need these 2 slopes to answer 11, 12, and 13. 11, why do graphs 9 and 10 have the same ratio but they're different lines? 12, how could you differentiate between the slopes of these lines? And 13, how does the rise relate to the run of a negative slope affect the steepness of the line? 1 minute on these 3. Should have 1 sentence for each. All right, number 11. Again, one of the lines is going down from left to right, which is why we get a negative slope on that. And number 10, this one's going up from left to right, which is why it has a positive slope. How can you differentiate between the slopes of these lines? Again, one is negative, one is positive. And 13, how does the rise rise relate to the run of a negative slope affect the steepness of the line? It didn't. The slope on number 9 is just as steep as the one on number 10. It's just going in a different direction. So it depends on, I guess, where you would want the steepness if you were to use this for other examples. All right, number 4. We're going to say this one has 3 triangles drawn on it, even though you could say it has a 4th one. Now what the heck? I guess we can try find all 4. You guys take a minute and find the ratios for all 4 of these triangles. On number 15, take a minute and find the rise and run for all 4 of these triangles. All right, each of these 4 should give us a ratio, simplified, that's -3, which is the same as 14, right? Again, it's negative because it's going down, and then for us, we'll say it's going to the right. So the slopes on these, on number 14 was -3. Number 15 had a slope of -3. Are the ratios for graphs 14 and 15 positive or negative? Well, we already know they're negative. How do we know? Because they're going down from left to right. 17, why are the slopes for graphs 14 and 15 the same if they're different lines? Well, they have the same ratio of rise to run, simplified, it's just they're in different positions on these. All right, that's it for the lesson. Thanks for watching, you guys. If it helped, give the video a like and subscribe to the channel, and leave a comment below on how it helped you. Or if you have questions, just comment below too.